Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Arman Hakim Nazili. Allow me to present our study forecasting LK45 index stock price using hybrid ARIMA gauge model and walk forward valuation. It is our agenda today. We first start with introduction and then theory, model implementation, results and analysis, conclusion, and the last is references. Let's start with the introduction first. Investment promise investor two things, profit, but also risk. Smart investor will make a prediction to the stock which he invest or not invest. Okay, so we need predict or forecast the stock price in the next day. For forecast time series data, Box and Jenkins in 1970 used or introduct an ARIMA model. And then Tim Boleslav in 1986 introduced gauge model. In 2014, Indian stock price is predicted or forecasted with a combination of those two models, titled or namely ARIMA gauge model by Narendra and Reddy. In 2020, Andrew Nielsen used an artificial neural network named Gated Recurrent Unit Model to predict the stock price in Indonesia. And we use ARIMA gauge model with walk forward valuation to predict or forecast the stock price data, same with Andrew Nielsen in 2020. Now is the theory. We introduce the ARIMA first. ARIMA is combination of two time series model AR and model MA with the differencing process. So AR plus MA we call them as ARIMA. To building the ARIMA model, we do two things: model identification and parameter estimation. Model identification, we use ACF and PACF, and the parameter estimation, we use method named MLE or maximum likelihood estimator. And then we introduce ARCH, but we use the generalized of ARCH in this study called gauge. This is the model, and this is the property of the variables. For the residual or error value, we use two calculation called by RMSE, root mean square error, and MAE, mean absolute error. And next agenda is model implementation. This is the data we use in this study. We use LK45 index, which consists of 45 stock price in Indonesia. But we only use two data to forecast, that is BBCA, Bank Central Asia, and TKIM data. Later, we will explain why we only use these two data over the 45 data in LK45. We use data from 1st January 2015 until 1st January 2020. The 5 years data. Okay, this is the explanation why we only choose two from 45 data. We counting the volatility. This is the formula. Okay, this is the 45 data. We count the volatility overall this data, and we found that BBCA and TKIM is the most extreme volatility in this data, which means BBCA is the data with the lowest volatility, while TKIM is the data with the highest volatility. So we conclude these two data will represent all the 45 data. We use the lowest and highest volatility. And the data observed, the data consists of several columns: open price, high price, low price, close price, adjustment cost price, volume. We only use cost price. Cost price is the stock price in the close the closing day. Okay, BBCA data and TKIM data, we split those data into two data, two data, two data training 80% and two data testing 20%. Data training is data which fitted to the model to obtain the parameter, to estimate the parameter, while the testing data is data for checking the accuracy to comparing with the forecast result later. And workflow validation is used to update the parameter. So imagine we use 6 data to fit the model. We estimate the parameter, so we get the equation, and we can forecast or predict the next data, the Y7. And we update the data training to become the previous is Y1 until Y6. We update it to become Y2 until Y7 predicted we get before. We fit again to the model. We obtain again the parameter, and we predict. We get the predict of the next data, which called Y8 star. And repeat the process again. We update again the data training, Y3 until Y8 star. And then we get Y9 star. This is the workflow validation method. Okay, so this is the workflow. We have the data. We transform the data into log. So the value, the real value of data, we transform to log value. So the interval of data is not too wide. We build the ARIMA. We estimate the best order with ACF and PACF. And then we calculate the AKIK information criterion. Estimate parameter with MLE. We get the residual, we get the error. So the error, we can build the gauge, because the gauge is built from error from ARIMA. So we called it hybrid ARIMA gauge. And the ARIMA gauge now be able to forecast the next value. And the forecast result is used again to update the data training. So we estimate again the parameter, and this process is repeated until we get all the forecast data we need to compare to data testing. Until we stop forecasting. After we stop the forecasting, we calculate the error or the residual. Okay, the data is pre-processing before we fit to the model. We do the differencing, we do the log transformation, we do the split before. This is the explanation about how to estimate the order of ARIMA with HF and PACF. And we also count the AIC to obtain the best order for ARIMA. We do MLE for estimate the parameter of ARIMA. We also use MLE for estimate the parameter of gauge. And we do the focal validation as explained before. For BBCA, we use 971 data training and 242 data testing. It is a 4:1 ratio, 80% and 20% of data. While the error calculation use this formula, as explained before, we use RMSE and MAE. Okay, so this is the result. The best order of ARIMA and for BBC and TKIM is ARIMA 111. The P is 1, the D is 1, and the Q is 1. And the gauge we obtain 11. This is our R code to do this study. Okay, this is the BBCA. We get this result, and we plot this. Just take a look at the right side of the graph. The green line and the red line is stacked. So it is very close between the actual and the forecast value. We do the same for TKIM data, and the forecast and actual value is very close. But if we zoom in the picture, maybe we will see that there is a little gap between them. Okay, we continue to calculate the error, and here is what we get. We compare it with using only ARIMA, and we compare it also to Andrew Nielsen's result when he using GRU, artificial neural network. Okay, so let's see that our ARIMA gauge error for BBCA log data or in the original data, BBCA 23.9 the error for the original data, the second row, while in ARIMA it is so big, the error is so big, which is 1,210, while in GRU 455. So our ARIMA gauge predict more accurate, predict better than GRU or ARIMA. Okay, here is the conclusion. If we compare the error, compare the RMSE and MAE from ARIMA gauge to the same data with Andrew Nielsen conduct in his study using GRU and to ARIMA only, which we conduct in this study, we get that the ARIMA gauge is the best for forecasting this data. This data with high volatility in LQ, the highest volatility in LQ45, and the data with the lowest volatility in LQ45. The ARIMA gauge is doing better than GRU and ARIMA only. Here is our references. And the acknowledgement, I would like to thank the RPM UI and the RPM FMPA UI for fully funded this research via Hibah Kita 2020. Sorry, this is a typo. Oke, thank you. Assalamualaikum.